When we have two lines and they intersect at a common point, we form angles. And these are the things that we are going to discuss today. The kind of angles that are formed when two lines intersect. And we will name them as the pairs or the relationship of angles. So we will have first the first kind. This is now the adjacent angle. So by definition, it states that adjacent angles are two angles that have a common side and a common vertex. Again, these two conditions must be present for us to consider a certain angle or two angles are adjacent. So they should have a common vertex. So as you notice, this point that we can see here will be the considered common vertex for these two angles. So we have here, if I will name this as my ray AB, and then this one as my ray AC, and the other one as my ray AD. I can say that this point, which is now the vertex, which is point A, is the common vertex of your angle BAC and the angle CAD. So these are the two angles which we are now saying that they are adjacent. Okay, now they should have a common side. And what is that side which is common to both the BAC or the angle BAC and the angle CAD? That is, of course, your ray AC. Okay, this is now the ray which is or the side which is common to both of these angles. So again, the two conditions are satisfied. Therefore, we can say that your BAC and your angle CAD are adjacent angles. Next relationship, we have here vertical angles. So vertical angles are two angles formed by two intersecting lines, and they have a common vertex but no common side. We will see two pairs of vertical angles in our example. So if I will name this as my angle 1, that is vertical to angle. If I will be having this as angle 1, angle 2, and then this one is angle 3, and I will name this as my angle 4, then we can say that angle 1 is vertical to angle 3, and 2 and 4 are also pairs of vertical angles. And what do we need to understand about vertical angles? They are always equal to each other. So when I say 1 and 3 are vertical angles, then I can conclude that whatever measure that I have for angle 1, that is true with angle 3, and also the same with 2 and 4. Now, a simple proof to that is when I let my angle 1 be equal to a certain measure. Let's say, for instance, this is equal to 100 degrees. Okay, so if I will let this be equal to 100 degrees, we can have this whole line. So as you notice, angle 1 and 2 form a certain relationship. I will be discussing this later, but we can make use of our linear pair. So when you say linear pair, that is that has a sum of 180. That simply means that 100 plus that 80 will give us an answer of 180. That means, or that will make the measure of angle 2 equal to 80 degrees. And if you are going to form or look for the measure of the angle 3 here now, again, this angle 2 and 3 are again linear pairs, meaning the sum is also equivalent to 180. And so if one of the angles is 80, I could just have this one equal to 100 degrees. So it will be proven here that these two angles are equal. And then definitely the angle or the measure for your angle 4 is equivalent also to 80 degrees, which is now the same with your angle 2. So that is now your vertical angles. So another condition, they have a common vertex but no common side. So as you notice here, if you are considering your angle 1, we will be having this side. Okay, I will have this side for the angle 1, while if I have the angle 3, the ones that I will be considering are these two sides. So there is no side which is common to both of them. Okay, so that is now your vertical angles. Let's go to the next kind or to the next pair of angles. And that is now your complementary angles. So when you say angles are complementary, they mean that, or it means that the sum of the measure is equal to 90 degrees. So that means to say that if you are going to add the two measures, they form a right angle. So the sum is always 90 degrees, which simply means that if I let this angle, suppose this is angle 1 and this one is angle 2, and the measure for angle 1 is, for example, 25 degrees. Okay, if this is 25 degrees, therefore, for me to find or figure out the measure of angle 2, I just need to subtract now from the supposed sum, which is 90. So subtracting 25 from the 90 degrees, we will now be getting a difference of, you have to regroup there, so that becomes now a 10, and then of course this will become 8. 8 subtracted to 2 is equivalent now to 6. So that sum or the measure of your angle 2 now is equal to 65 degrees. And if you are going to check, or if we are going to check this, this should get us, or this should give you a sum of 90 degrees. So 65 and 25 is equal to 90. So that is that is the relationship of complementary angles. Now, how can we deal with problems regarding complementary angles? So we have here one example of a problem involving uh, complementary. So find two angles such that one angle is 20 more than the other angle. So there must be a missing word here. So find two complementary angles. So there should be the word. Okay, so if that is the case, we will now have find two complementary angles such that one angle is 20 more than the other angle. Okay, so the thing here is we will be forming a certain equation that will represent the two angles. So one angle, we have missing measure, and then there is another angle now. That means this measure is 20 more than. So when you say 20 more than, that simply means that whatever the value that we are looking for, we need to have an additional 20 degrees. Okay? And of course, since we are dealing with complementary angles, once we add them, the result that we are supposed to get is 90. Okay, again, so find two complementary angles such that one angle is 20 degrees more than the other angle. So we are having a certain angle plus another angle which is 20 more than this angle is equivalent to 90. So we will be making use of the variable x because we don't have any measure for that. And that's the one that we will be given. So again, the thing that we are doing now is trying to look for two angles which are actually complementary, and one is 20 more than the other. Okay? So using now our representation having x plus the quantity of x plus 20, we will be solving this. Okay, so we will be solving this like solving equation with one variable. So we will combine this x. So x plus x, these are actually now the two missing numbers. So we will let that be equivalent to x. So 2x plus 20 is equal to 90. Okay? So we have the result. We can actually do this by using working backwards. Okay, so we have working backwards 90 minus, because this is a plus 20, we are going to subtract 20. So we can now have 90, and then the opposite of your addition there is minus 20. And then whatever the result that you are getting there, you have twice the number will give you a result of this. Therefore, the opposite operation of your multiplication by 2 is division by 2. So we are going to divide by 2. That is how you can do it by working backwards. So when you have 90 minus 20, that will result to 70. So 70 divided by 2 is equal to 35. That means to say the value that we are looking for is 35. And then of course, if that is in the measurement of a certain angle, there should be the degree sign. Okay, so if you are going to check and let your x be equal to 35, going back to our equation, x plus the quantity of x plus 20, the answer that we are supposed to get is equal to 90 degrees. And here, since we found that the value that we have is 35 degrees, we are now going to change that. By substitution, we will have 35 plus the 35 again plus the 20. Okay, and then we will see if that is correct, or the sum that we will be getting is equivalent to 90. So again, what we are doing now is the checking. So 35 and 35, that gives us a sum of 70 plus the 20. So definitely that gives us a sum of 90. Now let's go to the other condition. So one angle is 20 more than the other. So remember, this is this 35 plus the 20 refers to the measure of the other angle, meaning the two angles that we are looking for is actually a 35-degree angle, and the other one is 35 plus 20. So that gives us a sum of 55. And you can ask yourself, is 55 20 more than 35? Definitely yes, because if you are going to subtract this, the difference that you will be getting there is equivalent to 20. Okay, so that means if you are going to put it here in your angle or in your illustration, one angle is 35 degrees, while the other one is a 55-degree angle. Okay, and then the condition is satisfied that one angle is 20 more than the other. And again, they are complementary. That means the sum is equivalent to 90 degrees. Now this portion is actually working backwards, but there is another method that is being used, and that is by trying to solve for the value of x, and that is with the use of your equation. So what are we going to do? We will just have 2x. You have to leave all those with the variable on the left hand side of your equation, and then all the constant will have to be on the other side. So we will now have 90. You just have to copy the 90. Now there is a need for us to change the sign. So the plus 20 here is the same as now the minus 20. Actually, this is still the same as your working backwards, the one that we did a while ago. So we have now 2x is equal to 90 minus 20. Of course, the answer there is equal to 70. And then divide both sides by 2. Okay, you divide the number by whatever the coefficient of x that you can see, and therefore 2 divided by 2 is equal to 1 already. So 1 times x, that will give you an x. So x is equal to 70 divided by 2, that is equal now to 35. So therefore, we also got the same answer. And then just put now 35 plus 20 for us to find for the other measure of the other angle. Okay, let's have another example for this. Okay, here, one of the acute angles in a right triangle measures 43 degrees. So what is the measure of the other angle? Now we know that a right triangle is an angle or is a triangle with one right angle. So we need to understand now that one of the angles or the two angles in a right triangle are always complementary. Okay, that is one thing that you have to remember. This is a right triangle, and then always remember that this one is already 90. And since the sum of all the angles in a triangle, whatever kind of triangle, is 180, therefore we have this one as complementary angles. Whatever the sum or whatever these two angles here, when you have angle 1 and angle 2, they will always be, again, the measure of angle 1 plus the measure of angle 2 will always be equal to 90 degrees. Okay, you have to always remember that. Therefore, the two angles are complementary because their sum is 90. And so, one of the angles is 43. So, if I am letting angle 1 as 43 degrees, what's the measure of the other angle? Okay, so we just have to subtract 90 minus the 43 which is now the measure of your angle 1. So the answer for that will become 47. Okay, so the measure for our angle is, or for this problem, is 47 degrees. So those are just some examples that you might encounter when you are dealing with complementary angles. Okay, let's go to the fourth, which is the last now, which is supplementary angles. So supplementary angles are two angles whose sum of measures is 180 degrees. Okay, so supplementary form a linear pair. So when you have, for example, a certain measure here, which is if I will let this angle 1 equal to 120 degrees, by definition, we know now that this one will automatically be, okay, I will name this as my angle 2. It's just the difference of 180 and 120. And so 180 minus 120 is equal to 60 degrees. Okay, so the thing there is, if you are dealing with supplementary angles, always bear in mind that you have 180 as the sum. So that, for example, you are given a measure of A here, which is a variable. Okay, suppose this is A. Therefore, the measure that I will be giving for the supplement will simply be 180 minus A, because there is no measure, or the A is in terms of a variable. So whatever that value is, you just have to subtract 180 and that variable that you have. Okay, again, supplementary angles are angles with the sum of 180. So let's look into some application of this problem. The first one, find two supplementary angles such that one angle is 3 times larger than the other. Again, find two supplementary angles such that one angle is 3 times larger as the other. So again, the thing here is we are looking for two angles. Okay, so this is the first angle and then another angle. And of course, since they are supplementary, we will be equating them to 180. Okay. But we do not know those angles. We just have this condition that one angle is 3 times the other angle. So if I will let one angle be x, because I do not know that, I will be representing that by x. Therefore, with the use of this 3 times larger than the other angle. This one is a certain expression now that whatever the value of x, it is 3 times. So that means it will become 3x. Multiply whatever the value that you have there by 3, and that's the measure of the other angle. Okay, so if you want to show that, or if you want to have that in a certain no, it should be a straight one. Okay, again, you should have now your, okay, so this is now a supplementary angle, meaning you have a certain angle which is 3 times the other. Okay, when you look into the measure. So what are we going to do here? We just have to add x plus 3x. That is now equal to 4x. And then is equivalent to 180. And then we divide. We divide this by 4 because we simply want the value of x. So dividing both sides by 4. Okay, we are now canceling the 4 here. So 4 over 4, that is now equal to 1. 1 times x will simply be the x. So x now is equal to 180 divided by 4. So that will give you an answer of 45. So 45, and of course, since we are dealing with angles, we will now put the unit of measure, which is 45 degrees. So this is now the x. We are going to find for 3x, which means you are going to multiply 3 by whatever value that we got there. So 3 times x, which is 3 times 45. We are now multiplying 3 times 45. And the answer that we will be getting there is equivalent to 135 degrees. Okay, so these are now the two measurements that we have. So one angle is 45 degrees, while the other angle is 135 degrees. And the condition is satisfied that one angle is 3 times the other, because 3 times 45 is 135. And another condition, their sum is 180. If we are going to add 45 and 135, they should be supplementary, which means that their sum must be equal to 180 degrees. Okay, and let's have another one. Okay, find supplementary angles such that one angle is 65 degrees less than the other angle. Again, find two supplementary angles such that one angle is less than the other angle. So there must be find two supplementary angles such that one angle is 65 less than the other angle. So what do we have here? Again, we will now let one of the angles be equivalent to x, and then we are going to add that to the other angle, satisfying now the condition that that is 65 less than the other angle. Okay? So since we have that expression, if we have the original measure as x and the other angle is 65 less than, we will have to subtract. So x minus 65. And after that, we have here a sum of 180 degrees. Okay, so that is how we are going to translate this problem into this mathematical statement. So it is very important that we are able to analyze and translate the problem into a mathematical statement. Okay, so if you are going to do that, let's remove first the closing symbol or the parentheses. So we will now have x plus x minus 65, and that will be equivalent to 180. Okay? So again, combine the x here. So x plus x is equal to 2x. So there is 2x. And since we want to do the working backwards or simply using now or solving this with your equation, the minus, okay, the minus 65 here becomes plus 65 on the other side of your equation. Okay? And then here, what do we have? We have 2x and 180 plus the 65 will give us an answer which is 245. Okay? Now, there is something wrong with this. So, this is supposed to be 2x. Okay? Now, you will notice that division is not exact. When you divide 2x by 2, the answer there will become x. But when you divide the 245 by 2, you will notice that the answer that you will be having here is 122.5 degrees. Okay? So 122.5 degrees is the measure of the other angle or the first angle that we have. Okay? So after getting now your 122.5, which is the value of your x, we will now get the x minus 65. So in here, since we are now having x minus 65 pertaining to the measure of the other angle, what are you going to do? Again, remember that your x is 122.5. So we will now get that one. So 122.5, and we are going to subtract 65. Okay? And from here, you will have an answer. So if you are going to subtract now 122.5, there is a decimal number that we will be getting there. So we have now 0.5. And then we have to regroup, making this one equal to 12. So 12 minus your 5 is equal to 7. And then this becomes 11 minus 6. That is now equivalent to 5. So we are getting 57.5. This is now the other angle. Okay? So one of the angle is 122.5. The other angle is 57.5. So how are we going to check if we are correct? The sum of these two angles should give us 180 because they are supposed to be supplementary. So if you are going to add them, okay, so that gives you a 10. You have to regroup. This is now 10 also. We have to regroup 1, and then this will now become 1, and then 8. So, or 8 and then 1. So 180, you can drop now the 0.0 there. That is already meaningless. So that condition is satisfied. The sum, they are supplementary, so the sum is 180. What about the difference? So you have to get again 122.5, and the difference that we are supposed to get there is what? 65. Okay, because one angle is 65 less than the other. So we are going to subtract that. So again, you have a 0 for this because 5 minus 5. And then we have to do the regrouping. Therefore, this becomes now 12 minus 7, that is 5. And then you have to regroup, and this becomes now 11. And therefore, the 1 or 11 minus 5 is equal to 65. So again, we drop the 0.0 there. Okay, which means that the conditions are satisfied. And so, the answer to this problem, you can now say that the measures of the two angles are, first is 122.5 degrees, and the other angle is 57.5 degrees. Okay, so these are now the answer for this problem. So that is how you deal with supplementary angles.